Assalamu alaikum.
Walaikum assalam, sir. How are you, sir?
Alhamdulillah, fine. How are you?
Alhamdulillah, fine, sir.
So, do you have any doubt from last class? Khalid? Salman?
Assalamualaikum, sir. No
Alaikum
doubt.
salam. Okay. So, we have just started gravitation, in which I defined you about gravitational force. We have just defined gravitational force between any 2-point masses. But now, if you have to calculate for more than 2 masses, then how will apply? So there is a concept which is called superposition principle. Force due to system of point masses. Suppose you have a space there is a particle at this point, another at this point, another at this point, at this point. Let's say this is M1 at position R1, M2 at position R2, and so on to Mn at position Rn. All are applying force on this mass m0, which is at r0 position from origin. So according to this principle, superposition simply means in physics addition of two terms. So F1 or this m1 will exert gravitational force or attractive force on this m0 along this direction, as gravitational force is always attractive. So m1 will tend to pull this m0 by a force f01, force on naught by 1. Similarly, there will be another force on m0 due to this m2 along this direction. So it will be f02, as gravitational force is a central force which acts between line joining the 2-point masses. Similarly, for third mass or nth mass, force will be along this direction, so it will be F0n. Is it clear, Hamza?
Yes, sir.
So according to this principle, first statement is the force between any 2-point masses, such as F01, F02, F0n, will be independent of each other. It means if there is interaction between 1 and 0, then F01 will be unaffected by F02, F0n, and so on. So first is the force between any 2-point masses will be independent of force between other masses. It means F0 will have no any impact on other forces, Similarly, F02 will have no any impact on other forces. Each interaction will be always unique between these two masses. So the net force acting on particular mass, we are considering M0, on which some forces are acting F01, F02, and F0n. So as these quantities are vector quantity, so sum of all forces acting on this M0 due to system of point masses will be equal to vector sum of all individual forces. So next is the net force or resultant force acting on a particular mass due to all point masses is equal to vector sum of all individual forces, which means F net acting on M0 mass will be F01, F02, and so on to F0n. Hamza, is it clear?
Yes, sir.
Salman, any doubt?
No doubt.
I'm defining you these two different statements. Give an example. Just write it down first.
Done, sir.
Salman, you have written.
Yes, sir, done.
Hiba, Hamza.
Yes, sir. Done.
Okay. Suppose there is an equilateral triangle on which we have M, 2M, and 3M. Let's say this is A, B, and C. So you have to calculate net force, find net gravitational force on mass placed at B. So let me define you how to approach this. First, try to check what are the interaction for this particular point mass placed at B. So you'll say there is one interaction towards A So this point mass m will apply gravitational force on this mass 2m along itself. So it will be force on B by A. Similarly, point mass 3m will apply a force on it along this direction. So it will be force on B by C. So according to the first statement, these two forces will act on point mass 2m individually or independently. There will be no impact of one over other. So force on B by A equals to G, product of masses. So it will be m into 2m by square of separation between them. So L square. So it will be 2 times of gm square by L square. Is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Similarly, force on B by C. Salman, tell me what will be the formula for this B into C? For gravitational force, we just need capital G m1 m2 by r square. So what will be m1 in this part? So it will be 2m. m2 will be 3m. So it will be G m1 m2 divided by square of separation. So it will be L square. Is it clear? Salman?
Yes, sir.
So 2 into 3, it will be 6 times G m square by L square. Now, try to write these two terms in simplest form. So if we take this particular term to be F, so this will be 3 times of that part. So we can write it as 3F. Hamza, is it clear?
Yes, sir.
Now, to take the resultant of these two forces as they are acting at some angle, since an equilateral triangle, inclination from this point to this point will be 60 degree. So according to the magnitude of resultant of two vector, F net equals to root under F1 square, F2 square plus 2 times of F1, F2 times cos theta. Put the value of each term and simplify it. Try to solve. Let me solve. F1 is just F square. F2 is 3F. So it will be 9F square. 2 times of first term into second term times cos 60, 1 by 2 root under. So this term and this term will cancel out. So you'll get F square 9F squared plus 3F squared root under. So 1 plus 9, 10 plus 3, 13. F squared root under, or it will be under root of 13 times F. As we have considered F as 2 times of gm square by L square. So it will be 2 root 13 gm square by L square as net force. Good, Khalid. Salman, is it clear?
Yes, sir, I got this answer.
Good. Hiba, any doubt?
No, sir.
Nikhil, are you there? You all have written?
Yes, sir.
Suppose you have M find net gravitational force on 3m. Try to find Hamza. Any problem?
No, sir, doing it.
Okay. Just see, this is A, B, and C. So there will be a force on this B from A. So it will be along this direction. Force on B by A. So this will be equals to G M1 into M2. So M1 is M and M2 is 2M. Separation between these two terms is D by 2. So square of it will be D square by 4. So on rearranging, it will be 8 times gm square by d square. Khalid, is it clear?
Yes, sir.
Similarly, towards right side,
Sir, how it will be 2m? It should be 3m, right?
just 1 minute. So m into 3m. So 3 into 4, it will be just 12 times gm squared. Okay. Now for the second part, from C part, there will be a force towards this direction, force on B by C. So it will be G, product of masses, 2m into 3m, divide by square of separation. So 2 into 3, 6 into 4, it will be 24 gm squared by d squared. Now, as these two forces are acting on this 3m in opposite direction, so net force will be, which of the two forces is stronger? So it's force on B by C. So F on B by C minus F on B by A. This is 24 gm squared by d squared, and this is 12 gm squared by d squared. So it will be 12 gm squared by d squared. Is it clear?
Yes, sir.
Okay. You all have written?
Yes, sir.
Okay. Let me give you a last question of this part. Two-point d distance apart. If they start revolving due to mutual gravitational force, find velocity of revolving. Let me give you an idea how to approach this problem. Suppose you have any two-point object which must be at some distance d, initially like this. So due to this gravitational force between them, this entire system start revolving with respect to one another. So to revolve a particular system, there should be some necessary centripetal force. So first, this mass and this mass must be applying gravitational force in between them. So there will be a force of gravity due to this point mass on this along this direction. And to revolve this particular system, there should be some necessary centrifugal force to balance this part. So equate these two forces for this point mass, you will get velocity of revolution of the system. Is it clear? Just 1 minute, I'm defining you one more. We have 2 point masses, this and this, separated at some distance d apart. So there will be gravitational force in between these two terms. Now, due to this gravitational force, this system start revolving about one another in this particular circular path. So there should be some centrifugal force acting on each point particle in outward direction, which must be balanced by this particular gravitational force. Or you'll say the necessary centripetal force to revolve this system around this circular path will be provided by this gravitational force. So just equate these two forces, you will get amount of velocity of revolving. Hamza, is it clear?
Yes, sir.
So we had formula for centrifugal force or centripetal force as mv square by r. Just equate this term to gravitational force. R will be nothing but half of separation between two. Try to solve. Salman, any doubt?
No, sir, no doubt yet.
Okay. Khalid, you have solved? Hiba?
Sir, I'm
Hamza, you got the answer?
Not yet, sir, but almost near.
Okay. Just see, we have to equate gravitational force with centrifugal force. Fg is G, product of masses by square of separation between them. And Fc is mv square by r. Put the value of r to be d by 2. So it will be gm square by d square equals to mv square by d by 2. This m and this m will cancel out. This t and this t will cancel out. So you will get v equals to g m by 2 times of d root under. Salman, is it clear?
Yes, sir.
Hamza, any doubt?
No, sir, no doubt.
Okay. Khalid, is it clear? You have written?
wait, sir. Last one.
Okay.
Done, sir.
Hiba,
Yes, sir. Done.
okay. Next we start with acceleration due to gravity. Suppose you have Earth and a point mass is placed on this particular surface. M, this having capital M. Distance between these two terms will be radius r. So gravitational force between these two objects will be g mm by separation r squared. Now, if you have to calculate acceleration of each body due to the influence of this gravitational force. So first, acceleration of Earth towards object. So A equals to force by mass. So in this part, as mass of Earth is very large, so that acceleration for this will become very small or negligibly small as it tends to zero. So you'll say as m is very large, so A becomes, or acceleration of Earth towards object becomes significantly very small, so it will be approx tends to zero. Now for this object, acceleration of object towards Earth. So it will be A naught force divided by mass of it. So if you put the value of force, it will be G mm by r square times m. This m and this m will cancel out. So you'll get G m by r squared. So on putting all the values, you will get 9.8 meters per second square. This acceleration is also called acceleration due to gravity. The acceleration with which all object will be attracted towards center of Earth is called acceleration due to gravity. The acceleration with which all object will get attracted towards center of Earth. Salman, is it clear?
Yes, sir.
Okay. Hamza, any doubt?
No doubt, sir. Done, sir.
Okay. So we can write gravity equals to G times m by r square. You may convert this mass in terms of density. So mass equals to density into volume. As Earth is a spherical body, so its volume will be 4 by 3 pi r cube. So 4 by 3 rho g r. So we may write gravity in terms of mass or in terms of density as well. So you will be asked a question, percentage change in gravity related to mass and radius if it is less than 10%. So for less than 10%, we just use the error concept. So we have G equals to capital G m by r square. So delta G by G into r into 100 equals to m raised to the power 1. So 1 m by m into 100. R raised to 2. So it will be 2 times of r into 100. So according to the question, you may write percentage change in mass in this part. You may write percentage in radius in this part to get percentage change in gravity. I'm giving you an example related to this. Suppose if the radius of Earth is decreased by 2%, keeping mass constant. Find percentage change in gravity. So according to the above relation, we can write delta G by G into 100 equals to delta M divided by M into 100. So this will be percentage change in mass plus 2 times delta R divided by R into 100. Now in this part, according to the question, we have constant mass. So for constant term, difference will be 0. So this entire part will be 0. Now the next is percentage change in radius is 2%. So put the value of this entire part to be 2. So you will get 2 into 2 equals to 4%. Now next question will be whether this percentage change in gravity will be increasing or decreasing. So you will say, according to the relation, gravity equals to Gm by r square. So gravity is inversely proportional to radius. So if radius is decreasing, so gravity must be increasing. So it will be increased by 4%. Hamza, is it clear?
Yes, sir.
Salman, any doubt?
Yes, sir. The G, like you wrote G is equal to Gm by R square, right? That part I didn't understand. Increase or decreased.
Okay. According to the formula for gravity, we have this term. Small g is gravity, capital G is gravitational constant, m is mass of Earth, and r is radius of Earth. So here gravity is related inversely with radius. So if radius is decreasing, so gravity must be increasing as they are related inversely proportional to each other.
Yeah, okay, sir.
Khalid, any doubt?
No, sir.
Okay.
Done, sir.
Salman, you are done?
Yes, sir, done.
So now we have to calculate factors affecting the value of gravity. Factors affecting gravity. First is depth. Suppose this is Earth having radius capital R to this point. On going towards its depth, let's say to this instant, radius of this particular Earth is R, and from this point to this point, it will be just small r. So depth of this point from surface will be small d. So r equals to capital R minus d. So in this part, radius is changing. Consequently, mass of Earth will also change. For this entire Earth, it will be total capital M. But for this small region, its mass will be much smaller. So we can use in terms of density as density of Earth will be constant. So on surface of Earth, gravity is 4 pi rho g into r by 3. I have written gravity in terms of rho and radius. Let's say this is the equation first. So at depth, it will be gd equals to 4 by 3 pi rho g, and distance from the center to that point is just a small r. Just divide these two terms. You will get small r divided by capital R. So gravity in depth d equals to g naught divided by r into small r, like this. Is it clear, Hamza?
Yes, sir.
Okay. We may rearrange this particular term in terms of that as well. So gravity due to depth equals to gravity on the surface by radius. Small r is also equals to r minus d. So you may write it as g naught 1 minus d by r equals to gravity at some depth d. So if depth is given, which means if you are going from surface to that particular point, so we can use this formula. But if that point is given from center, we can use the formula that is on the left side. So according to the given term in the question, we may write these two with the equations. Khalid, any doubt?
There probably has neck problems at night.
Okay.
Done, sir.
Okay. Now we may calculate weight depending upon this particular gravity. So as weight equals to nothing but mass times gravity. So on the surface of Earth, let's say W naught is equals to m times g naught. So at some depth d, it will be mass times gravity due to depth d. So if you put the value of gravity at depth d, it is equals to m times g naught small r by capital R. So it will be equals to W naught by R into small r. Is it clear?
Yes, sir.
Yes, okay.
Now, if you have to calculate percentage change in gravity or percentage change in weight, so percentage change in gravity or weight will be equals to gravity on the surface minus gravity on at some depth t divided by on the surface into 100. If you put all the value, you will get d by r into 100. like this. Hiba, any doubt?
No, sir.
Let me give a question related to this. If weight of a body on surface of Earth is 32 Newton, find its weight at depth of r/4 from surface. In this particular part, you have given weight on the surface of Earth, that is W naught, 32 Newton. Depth is R by 4. So you have to put weight at some depth equals to weight on the surface 1 minus D by R. Put all the values in this part and simplify it to get weight at some depth D. Hamza, you have solved?
No, sir, I'm stuck.
Okay. Let's say W naught is 32. 1 minus D is R by 4 into R. So this R and this R will cancel out. So 32. If we take 4 to be LCM, so it will be 4 minus 1. So it will be 32 into 3 divided by 4. So 4 in 8 time, 8 into 3, it will be 24 Newton. Is it clear?
Oh, yes, sir. Actually, I didn't take that R.
Okay. Salman, any doubt?
No, sir.
Done, sir.
Next is due to altitude or height. This is Earth. And we have to calculate gravity at any height. Let's say at this point. So from center, distance from the point, this point is R, and height. So total distance from this point from center will be small r. So small r equals to r plus h. So in this part, Earth will confine only to this point. So outside the Earth will be air whose mass is much smaller as compared to this entire Earth. So we can neglect mass of air. Mass of air is neglected. So we can write gravity in terms of mass. So at surface, gravity is gm by r squared. Equation first. At height, gravity due to height is g, mass will remain constant, and distance from center to that point is small r squared. Now on dividing these two equations, you will get gravity on height h divided by on surface, gm and gm will cancel out. So you'll get r squared divided by small r squared. So gravity due to height h equals to g naught times r squared by small r squared. Is it clear? Hamza, any doubt?
No, sir, no doubt.
Okay. Now there will be a question to draw a curve related to gravity and distance for this entire Earth. So in last part for depth, gravity due to depth is g naught times small r divided by capital R. So it is directly proportional to distance from center. Gravity on the surface is simply g naught, and that will be constant. If you write g naught in terms of this, so it will be this, and this will be gm by capital R square. And in this part, gravity due to height or outside surface of Earth, it is g naught times r squared by small r squared. So it will be inversely proportional to small r squared, like this. So if you plot a graph of this particular term,
Sir, what is GS again?
GS is gravity on the surface. So in this part, from center to that surface, gravity is increasing linearly till this surface when a small r equals to capital R having maximum value. And outside of this Earth, gravity is decreasing as inversely proportional to r square or rectangular hyperbola, like this. So this is variation of gravity with respect to distance from center to the outermost part. Is it clear?
Yes, sir.
Khalid, is it clear? Salman?
Yes, sir. Clear.
Okay, just write it down. You all have written?
Yes, sir. Done.
Hiba, any doubt?
No, sir.
Now we may rearrange this equation as if height is very, very small as compared to radius, or you'll say h is less than equal to 100 kilometer, for which we can rearrange this equation as gravity due to height equals to g naught times r square. We may write small r as r plus h whole square. So g naught times r square divided by, if we take r to be common, so it will be r square 1 plus h by capital R. Let me define you this part. Since I have to take out r to be common, so I have just multiplied and divide this term by r. And if you take out common r, so it must be squared. So it will be g naught times r square divided by r square 1 plus, I have taken this capital R from numerator. So we're left with this r and in denominator whole square. Now this r square and this r square will cancel out. So move this denominator part to numerator. So it will be g naught 1 plus h by r raised to minus 2. Now according to binomial expansion, 1 plus x to the power n, it will be 1 plus nx. So using this concept, minus 2 will get multiplied with this coefficient. So it will be g naught 1 minus 2h by r is equals to gh. So this will be another formula for variation of gravity with respect to height or altitude, but condition is height should be smaller than 100 kilometers. Iba, is it clear?
Yes, sir.
Done, sir.
Done, sir.
Let me give you a question related to this. Find depth at which gravity is same as that of 10 kilometer above the surface. Try to find. Hamza, got the answer?
Not yet, sir.
Just see how to approach this problem. We have to calculate depth at which gravity will be seen as this much amount of height. So this particular value is smaller than 100 kilometer or larger than 100 kilometer.
Smaller than.
So we can write gravity due to height equals to g naught 1 minus 2h by r, since this height is less than 100 kilometer. And gravity due to depth equals to g naught 1 minus t by r. So just equate these two terms and try to find d with respect to h. Then put the value of h to be 10, you will get d. Is it clear?
Yes, sir.
Salman, any doubt?
No, sir. No doubt.
So if you equate these two terms, gravity due to depth, gravity due to height, G naught 1 minus d by r times G naught 1 minus 2h by r. G naught will cancel out, 1 and 1 will cancel out, r and r will cancel out. So you get d equals to 2 times of h. So if you put the value of h to be 10 kilometer, so it will be just 20 kilometer. Hiba, is it clear?
Yes, sir.
Done, sir.
Salman, you have written?
Yes, sir, done.
Okay. So this is all about gravity and its different problem. Next is Kepler's law of planetary motion. Kepler's gave you these three different laws related to motion of planet around the sun. So first is law of orbit. It states all planet in solar system revolves around elliptical path like this. This is called major axis, and this is called minor axis, and this term is focus. So in which sun lies at one of its focus. So it will be at this point, and planet will revolve around this path. So at this point, planet will be closest to sun. So it is called perihelion. And at this point, planet will be farthest from sun. So this point is called aphelion. So according to this law of orbit, all planet revolves around the sun in an elliptical orbit, for which sun lies at one focus. Salman, any doubt?
No, sir. Can you show a bit the thing what you wrote?
Just 1 minute. Now, due to this particular law of orbit or due to this elliptical path, there will be seasonal change on surface of Earth. So the main impact of seasonal change is the orientation of axis of rotation. Let's say at this point, perihelion, orientation of axis of Earth is along this direction. So northern half portion of Earth will be facing towards sun. And at aphelion, it will be like this. So southern half portion of Earth will be facing towards sun. That's why summer in Australia and New Zealand is different from summer in India or northern part countries. Is it clear?
Yes, sir.
So seasonal change on Earth will be due to distance from sun as well as orientation of axis of rotation. So in this part, this northern part, summer, and in this part, this southern region have summer season. Khalid, any doubt?
No, sir.
Done, sir.
Salman, you have written?
Yes, sir.
Khalid, done?
Yes, sir.
Next is called Law of Equal Areas. Suppose this is sun and planet is revolving around it. So the line joining planet to the sun from this point to this point and from this point to this point. So this is the total amount of area served by planet on going from A to B. Similarly, amount of area served by this particular radius vector ongoing from this point to this point. So according to this law, if area ongoing from A to B is equals to area ongoing from C to D is equal, then time taken by planet to go from A to B should be equals to time taken by the planet to go C to D. So according to this particular law or law of equal areas, the line joining planet to the sun sweeps equal areas in equal time gap. So if area ASB equals to area CSD, then time taken by the planet to go from A to B should be equals to time taken by the planet to go C to D. Is it clear? Hamza, any doubt?
No, sir, no doubt.
Okay. Let me prove this particular part. First, write it down. Salman, you have written?
Yes, sir, done.
Okay. Suppose a planet is revolving around sun. So at any instant, it is at this point. In some time, it will reach to this point. So this is distance r, this is distance r. So the total angle inscribed in this point is delta theta. So the area served by planet ongoing from this point to this point will be this, P to Q. So area swept by planet delta A equals to, in product of vector, I had defined you how to calculate area of triangle. So it was A cross B mod divide by 2. So if you expand that particular part, you will get AB sine theta divided by 2. So we can write area of triangle as A half times AB sine theta. So in this part, we have A as R and B as also R. So we can write R square times sine theta. Is it clear? A cross B mod will define you area of parallelogram. So if you multiply it by half, you will get area of triangle. So it will be half of A cross B mod. Or if you expand this, you will get half A into B into sine theta. Hamza, is it clear?
Yes, sir.
I've taken A and B to be R in this part, and theta is delta R. So if theta is small, we can write sine theta equals to just theta. So we may write it as R square by 2 times just theta equals to delta A. Now divide each term by delta t and take limit. So we can write delta A divided by delta t. Delta t limit delta t tends to 0 equals to R square by 2 limit delta t tends to 0 delta theta by delta t. Now this entire part is nothing but dA by dt according to calculus. Similarly, this entire part is nothing but d theta by dt. So we can write dA by dt equals to R square by 2 times d theta by dt. Salman, is it clear?
Yes, sir. I
Yeah.
understand.
Now just dividing both side by delta t and taking limit delta t tends to 0 to make this particular part or change to be instantaneous. Now we can write as angular momentum. I defined you in last chapter, rotational part, equals to I times omega. I is moment of inertia, so it will be m times r square times omega, and omega is nothing but d theta by dt. So we can write r square by 2 into omega. So from this part, we can write r square omega is L by m. So put this term in this part, you will get dA by dt equals to L by 2 times of m. Hiba, is it clear?
Yes, sir.
Here L is angular momentum, which is equals to I moment of inertia, omega angular velocity. I moment of inertia for point object is equals to m times r square. Now, this term, which is dA by dt, is called aerial velocity, which is equals to L by 2 times of m. And last chapter, I defined you if torque applied on the body or system is 0, then angular momentum of this entire system is always conserved. So this is the basis of all Kepler law. So we can write this entire term is constant. Hamza, is it clear?
Yes, sir.
So if right hand side is constant, so dA by dt will also constant term. So dA is directly proportional to dt. Means amount of area served by the planet will be directly proportional to time taken by it. So for equal time, it will cover equal amount of area. Is it clear?
Yes, sir.
In equal time, it will cover equal area. Just write it down to this part.
Done, sir.
Done, sir.
Okay. Now we can define some other terms related to this. According to conservation of angular momentum at perihelion must equals to angular momentum at aphelion. So for particle moving at some velocity v, angular momentum equals to mass times velocity times distance. So it will be equals to mass times velocity times distance. So this m and this m will cancel out. So velocity at perihelion divided by velocity at aphelion equals to distance at aphelion by distance at perihelion. This is elliptical path. And let's say sun is at this point. So for a planet at this point, distance from this point to this point is RP, since this point is perihelion, and to this point is RA. So according to this diagram, we can see RA is much larger as compared to RP. So this ratio will be greater than 1. It means velocity of planet at perihelion will be greater as compared to aphelion. Is it clear?
Yes, sir.
Yes, sir.
So you'll be asked, is the planet move around the sun with constant velocity or having different velocity? So you'll say planet moves at different point with different velocity. So when it is closer to the sun, distance will be smaller, so velocity will be larger. So planet moves faster when it is closer to the sun. And slower when it is farther away. Salman, is it clear?
Yes, sir.
Okay. Just write it down. You all have written?
So just the last one.
Done, sir.
Done, sir.
Done, sir.
Khalid, done?
Yes, sir. Done.
Okay. So do you have any doubt till this part? In gravity or in this Kepler's law?
No, sir.
No, sir.
No, sir.
Okay. So revise this till this part and try to do some problem related to this. In next class, I will define you the third Kepler's law, that is about time period. Then we'll start gravitational field, gravitational potential, and so on. Okay. Okay then. Take care. Allah Hafiz.